Hello everyone, welcome to this course on electronic waste management issue and challenges. I am Arnav Kumar Pahari, I am the TA of this course. So, today we will discuss about the typical numerical problem that will be coming to your end exam as well as that is given in your assignment and in the video lecture also. So, as we know our course consists 4 modules typically. In the first module we have discussed about electronic waste quantification and its economic assessment. We have given some overview of health effects too, whereas in the next module we have elaborately discussed the health hazards due to informal recycling of electronic waste. Whereas in the third module we have discussed about the extraction of precious metal from the electronic waste, and in the fourth module, which is the last module, we have discussed the life cycle analysis as well as the legislation related to the e-waste management. Say for example, what is the salient features of electronic waste management and handling rules, as well as what is the present e-waste management scenario in different European countries and USA. So, first, basically our numerical problem will be coming from the first and second module, which is the e-waste quantification and its economic assessment, and in the second module the health hazards due to informal recycling of e-waste especially. So, we are going to let us start with the first module. So, in this module we are going to discuss about e-waste estimation using a time series model, and second we will discuss about estimation of material value of obsolete electronics. So, let us start with the time series model. So, this is our typical time series model. So, what is the time series model? You purchase some electronic items, or in a year for a state or for a country total purchase of electronics items are enormous, then it will become obsolete at its after its end of life period. What is end of life period? End of life period is different for different items. Say for example, for mobiles it could be 3 years, but for refrigerator it may be 7 years, 8 years, for television it may be 8 years, 9 years. So, it basically depends on the product. Once it is become obsolete, it can be reused, it can be stored, it can be recycled, it can be landfill. Okay. So, after its reusing, so what is the way of reuse? You can donate to your relatives, you can give it to your friend, you can give it to your sister. What is the storing? You can store it in your home. What is the recycling? You can recycle to the formal recycler. Like these days in India we do not have that much recycling facility. Mostly we are dealing with the informal recycling recycler, like Kavadiwala will come to your house and they will collect your instrument electronic. And third one, last one is landfill. So, reuse and stored is the intermediate option, and recycle and landfill is the final option. So, as we know, as it is intermediate option reuse and stored, so reuse item again can be stored, recycle and landfill. It can go to the option 2, 3, 4. Similarly, option 2 which is stored, it can go to 3 and 4, it can be recycle and landfill. Similarly, again stored item can be recycle, can be landfill, because the recycle and landfill is our last option. What is x1 to x11 that is given is the fraction of the obsolete electronics item for various end of life scenario. Now, we are going to the next slide. Before going into the calculation or before calculating the total amount of obsolete electronics items, you have to keep certain factors in your mind. What are the factors? If you will see these days in the news, the developed countries like USA, Europe, they generate lot of electronics product and they import to the third world country, sorry, they export to the third world country. Why? Because they send this to the third world country as a gift. So, this is called transboundary movement. In this case, in our model, you can say we can consider the transboundary movement, but we have not considered in this model. This is the drawback of our model. So, if you will see total ban of the illegal export of electronic item. On the other hand, we have assumed lifespan of the reused and stored electronics item are 3 years. It could be changed, it could be 2 years, it could be 1.5 years, it could be more than 3 years, 3.5 years, it could be 4 years, but that depends on your actual observation. These data all we have collected or shown to you is based on certain literature, certain data, and 50% of the reused item are further stored, whereas 20 and 30% items are recycled and landfill. This is another assumption. So, after its end of life period, you are reusing, you are first, you go back to the previous slide, if you will see it, see. So, after reusing you can store it, you can recycle it, you can landfill it. So, this period is 3 years. If you recycle your items, electronic items and stored it, we are assuming this value, we are assuming this time span is 3 years. Again, if you recycle your stored item after 3 years, these values also we are keeping constant 3 years. So, this is my first generation use, this is my second generation, this is my third generation. So, for all the cases we are assuming 3 years. It again similar thing, it could be changed also, it could vary. So, and 20 to 80% of the stored item which are coming to the third generation are recycled and landfill. These values all are based on the certain assumption. Now, we are going to the typical example. These are the data. Suppose you have the data of refrigerator under Kolkata municipal area. So, in Kolkata municipal area we have collected some data of sales figure of the refrigerator. These all are in numbers, these all are in numbers. So, if you will see these values are quite high, 2000, 2001 we have all the data. Now, if you have to estimate the what is the total amount of obsolete in 2016, total amount of obsolete electronics, as well as you can calculate what is the total amount of recycled refrigerator in 2016, what will be the total amount of stored refrigerator in 2016, what will be the total amount of landfill refrigerator in 2016. For that you need time series model equation, you know the basic data. So, how to estimate? So, how to estimate? We have been developed this equation. How we have been developed this equation? What, how to develop? This is the major things we have asked in the forum also. So, how it is developed? First thing, suppose you take refrigerator, its amount is X. Suppose in 2016, as I have already given the example, you want to determine all of the quantity, reuse quantity, stored quantity, recycle quantity, landfill quantity. How to calculate? First, say for example, in refrigerator, OK, what is the OK? OK is the quantity of the obsolete item for the year k. And you should keep in the mind the what is the lifespan of the refrigerator. Lifespan of the refrigerator is the 11 years. So, that means in 2016 those refrigerator had purchased in 2015 5 will become obsolete in 2016. That you should keep in mind, because in the calculation you most of the time we did do the mistakes. Most of the time we did the same mistakes. We are not taking into consideration the lifespan of the refrigerator, because if you want to, now this is the single example of refrigerator. Now if you include various kind of electronics, there are different types of lifespan. You have to take into account all of the thing. You have to take all of the lifespan of all the electronics item. Then you have to develop a step by step equation for each of the electronics item. And once you determine for each of the electronics item, you have to simply add, these are the amount of the stored item, these are the amount of recycle item, these are the amount of landfill item, these are the amount of reuse item. So, coming back to the example, say for example, in the refrigerator, say for example, this is the x number, assuming this is the x number. So, what will be the reuse item? 0.11 into x. X means this x number refrigerator I am just determining for 2016, say for example. So, this x number refrigerator become obsolete in 2016. So, it has reached is end of life period in 2016. Now, how to calculate the stored item? The recycle amount which reached at its end of life period in 2016 as well as which become obsolete in 2013, because the amount which became obsolete in 2016 we stored it for 3 more years as per the model. Similarly, for recycle items, if we will go back to the model, similarly for recycle items, if you look at the model, the amount which become obsolete in 2016, the amount which become obsolete in 2013, the amount which become obsolete in 2010. Similar way you have to calculate it for landfill also. This problem we use typically for our research purpose. You do not expect this kind of problem will be given to your end exam, but you should know the logic behind the time series model. Now, suppose you determine these are the total amount of obsolete refrigerator, obsolete reused refrigerator, stored refrigerator, recycle refrigerator, landfill refrigerator. Now, how to calculate? How to calculate economic value of this electronic item? How to calculate? There are two procedures. First, you can multiply the number with the weight of individual item. If you know the weight of the refrigerator, say for example y, so for what will be the total reuse item? 2175 into y, this much gram, say for example, or kg, whatever may be the case. Another way ki, you know the number, you go through the total metal content in a refrigerator, in a refrigerator. Okay. Like in the next slide we have shown it. See, these are the typical metal content in the different kind of electronic item. Here refrigerator is not mentioned, but we have the data for refrigerator also. So, if you look at, say for example, for the similar kind of you want to determine the value for a smartphone. So, what is the value for a smartphone? Column 10. So, column 10 is for the smartphone. So, these are the total metal content in a smartphone. Aluminum is 2.9 gram in one smartphone per unit, means one smartphone. Another is antimony. So, this way total metal content is given. So, you determine the total metal content and then you determine the total material value in a single smartphone, like we have calculated. It is coming around very small. See, this is for a smartphone 174.71, approximately 175 rupees. See, but when you look into the quantity, in a year the number of smartphone has become obsolete is into 10 to the power 6, say for example around 22.5 into 10 to the power 5 to, say for example I am giving one example, that suppose assume your smartphone total amount of the obsolete quantity of your smartphone is 2.5 into 10 to the power 5. Okay. So, if you multiply with 175, this is a huge amount that we are becoming landfilling, or otherwise we are send it to the informal recycler. And on the other hand, what is done by, what they have done, what informal recycler used to do, they collect this metal through unscientific way and sell it to the authorized recycler. That way they are earning money. So, this way you can calculate the total amount or total economic value of an electronic item. You can multiply with the number into total economic value. One second. You can multiply it with the number, you can multiply it with the, so total economic value of smartphone or any other electronics items or any electronic product is, one is number that is obsolete into value of a single item. Okay. This way you can determine. Otherwise, if you know the number, you can multiply it with the weight, and you can when you multiply with this is gram or kg, whatever may be, then you have to determine the value in terms of money, obviously economic value per kg or gram. Okay. So, this way you can calculate the total amount of economic value from a recycled electronic product, from a stored electronic product. The way you want to calculate, you can calculate it. So, in the first module what we have done till now, first we have estimated the quantify the total electronic waste for a city, for a state you can determine, for your city you can determine, for your state even you can determine, for your country like India you can determine for India using a time series model. That parameter, major things you should keep in mind, that parameters could be changed, these values are based on the certain assumption. Next, we have not considered the transboundary movement of electronic waste, that things can be included in this time series model with some special features. Next, we calculate the calculate the economic value of an electronics item. So, this is very simple, number into value of a single item or number into weight or economic value per gram of the electronics item. One thing you should keep in mind, that in the exam it may be given like these are the data 2014, this much amount, say for x amount, items has purchased electronics item in 2015, it could be Y, in 2016 it could be Z. So, this amount of, this is the sales figure. So, while calculating, suppose I have asked you or we have asked you that how calculate the total economic value of the item in 2017. So, what will be the total economic value in 2017? Say for example, assume lifespan is 3 years. So, which item become obsolete in 2017? Those which you have purchased in 2014. Do not say that we do not have the data in 2017, because the item you have purchased in 2014 will become obsolete in 2017, and then you use this value for calculation. Okay. So, thank you for the module 1. Next we will start module 2, which is related to the health hazards due to informal recycling of e-waste. Here we will discuss how to calculate different cancer risks, non-carcinogenic risks, and what are the different elements related, and we will discuss also different elements related to the health hazards. So, thank you for the module 1.